Okay guys, let's get started. Let's get started with today's lecture. Well, first of all, I hope you had a nice Easter break. I hope you didn't miss us too much, but you know, we have one more week. So, and actually today is going to be the last time I'm going to introduce new content. I might need next Monday to finish it up. So we're going to see about that. But then next week we're going to have at least one fully dedicated review session. I will catch up on some stuff that you might want me to explain a little more before the exam. But also on Monday, I hope to get started with that already. Yeah. So much about that. It was brought to my attention that some guys of you were supposed to have the tutorials on Monday, Easter Monday. You know, there was obviously no tutorial. I was told that these tutorials would take place next week. And that's sort of what my administrators told me. So, same time next week, Monday. Okay, well, we're getting closer towards the exam. So it's sort of the time for you to freak out. Getting there, maybe not yet, maybe next week. Yeah. But slowly keep that in mind. So I had the preliminary date of 8th of May, but I hope that it was communicated to you. Finally, these kind of things get communicated to you, but not to me. So I have to really dig down and kind of find somebody who tells me when the bloody exam is. Yeah. So apparently it's on the 8th of May. So keep that in mind. It is coming. Right? So it is coming, it is happening. Okay. So in that context, I have a few little questions for you in the first instance. Yeah, so take your phone, if you have a series like this right now. Oh, seriously, guys, man. What is it? So what is the exam preparation guide? Well, it's a document that I put together about giving you tips about what you need to do well in the exam. Remember, I told you when you do what I tell you, you will do well in the exam. It means you have to do some stuff, but I tell you what you have to do. And I introduced it just before, when was it? I think I mentioned it at International Women's Day. So it is on Blackboard. When you go through the syllabus on Blackboard, there is one entry which says exam preparation guide. It's a PDF document. So now you know what it is. If you haven't looked at it, I strongly encourage you to look at that. That's your way how you prepare for the exam. Yeah? So please have a look at the exam preparation guide. There I give you all sorts of tips on how you should approach this, yeah? Because I don't know what is relevant or what not. You know? So there I talk about that a little bit. Okay, another question. As I said, next week I'm going to have a review session, and you know, we can talk about some stuff again. So, which is the stuff that I should be talking about? Okay. Why am I not surprised, you know? I know these things, That's so funny. Manche Ecke. It's cool, no? It's nice. Okay. Okay. I'm going to ask that question again on Monday, because we will have then another session on Wednesday. So I want to give you the opportunity to give feedback on this. Because I could talk about all sorts of things, but let's talk about the stuff that you seem to care about. Yes. Okay. Thanks very much. I'm going to have a look at this in more detail and try to make something out of it. Okay, but now I actually have a question on the readings that you guys had to do. By the way, from the point of running a survey, this thing here is incredibly useless, right? Because you see what other people do, and then this sort of affects what you think, and then hang on, everybody else is saying that, maybe I shouldn't do that, and so on. Okay. So actually the right answer here is interval. It needs to be interval, all ratios scaled. This is the stuff that I'm going to talk about today. Yeah. But please have a detailed look at the readings. These things, you need to know the readings here. The mean is nothing else than calculating an average over something. In order to calculate the average of something, nominal, what would be nominal? Nominal would be, let's say, you have data and there's sort of males and females. What is the average of males and females? You can't really calculate an average here. Yeah? The same ordinal scale would be if something has an order, let's say, I don't know, do you go to the student bar very often? Sometimes, never. What is the average here? Again, you can't really calculate an average, because the distances between the different boxes that people might have ticked, they're sort of unclear. Sort of what, I don't know, if it would be, let's say, 10 times, 5 times, or 0 times, then you could calculate an average. But if you have like something like very often or sometimes, so you can't really calculate an average here. But you have an order. That's ordinal. An interval is actually as soon as we can calculate an average. But I'm going to talk about that today. So in that context, I had another question, but maybe I'm going to skip that, since you just got this wrong. There's just no point in me asking this question. Yeah. So what is the median of the following values? I don't know. I'm not going to have that, but I come back to that in the lecture now. Okay, so these are the things that I want to talk about today, or the next lecture. Probably I'm just going to cover the first two today, and then this version we might talk about that on Monday before we start to review it. Let me put this in the bigger context a little bit. Maybe that can help. We talked about these things, how the research process goes. You explore things, you plan it, you execute reporting, and I don't know. Then we jump further into these kind of things. We talked about different research designs, different measurements. All sorts of methods, like a survey, questionnaire, an interview, an experiment, and then we talk about sampling quite a bit, which is actually with whom do you do it, right? So the method is what are you going to do, and sampling is with whom are you going to do it, and then the next step, and I don't know, we don't have time to talk about everything on this here. You collect your data, and then ultimately you want to analyze your data in one way or the other, and this is sort of what I want to do with you today. Yeah? And this is sort of where these mode, median, and mean things come into play a little bit to describe data in a relatively simple way. Okay, and writing up, but we're not going to get there. So I want to talk about these 4 levels of measurements, and I could have talked about that in the context of measurement as well, but it sort of nicely feeds in what we're going to do next with the averages as well, so that's sort of where it kind of fits in here now. And with 4 levels of measurements, I mean these 4 things. Yeah? I mean these 4 things. And a level of measurement is basically, when probably, when I bring up the examples, probably you might understand this much more. Like nominal means you get data on something, they are male or female, or they have different ethnic groups, and so on, right? There's no order in there, there's no absolute zero, there's no relationship between these kind of things. So anyway, so what I'm going to do, I'm going to walk you through these 4 different levels of measurement, and then I'm going to link them to these ways of describing data, to analyzing data, which is ultimately mode, median, and mean. Okay, so nominal measures. Nominal measures are basically just distinct classes or distinct categories. Let's say, think of it maybe in the context of a survey. You're given a question, you can tick certain boxes. These are just distinct boxes that you can tick. Prime example is male and female. Now, if I run a survey and, I don't know, you tick a box, you're male or female, this is a nominal measure that I have. There are no quantitative properties attached to that. I cannot order these things. It's not that, I don't know, females are higher than males, or males are higher than females, or something like that. It just doesn't make sense. Or there's an average here. Doesn't make sense either. I can just say how many females are there and how many males are there. Right? And often these kind of things are dictated by what you are substantively looking at. The kind of the data variable that you have. And you need to think about the substantive content underlying it. Other examples would be country of origin. People tick a box, I don't know, they are from Ireland, or they're from the UK, or whatnot. You see, there's no order here. I cannot order these kind of things. But what I can do, I can count how many people tick this one box, right? And sometimes when you look into data sets, people use number codes to reflect these different categories. I don't know, let's say there would be a survey and I would have asked you about your country of origin, and then in my data set ultimately, there would be 1, and that stands for you being from the United States. Or there would be 2 that would stand for you being from Ireland. But now here the numbers, they don't mean anything. That's sort of the thing that you need to keep in mind, right? That these numbers here, it's just a representation, it's just a way of capturing the nominal thing. So a big mistake would be then to look at these 1, 2, 3, 4 and take the average over that. You see, that doesn't make sense. But it's an easy mistake to make. So that's basically nominal measures. And other examples, I don't know, could be yes or no questions. Or, I don't know, what are my musical preferences? You see, there's no average here. It's just distinct nominal categories. That's sort of what we call these kind of things. And these kind of things are driven by substantive grounds. So whatever you're kind of looking at, that sort of dictates what the measurement here is. And normally it's sort of like the simplest one. And maybe you'll see why it is the simplest one, because you can translate all the other ones, the more fancy ones, ordinal, intervals, ratio, you can translate them back into nominal measures. Right? Let's say if you would collect data about people's age, you could translate that back into age categories, where each category would be distinct from the other one, you see? But you would lose information that you could use to then calculate averages, for example. But anyway, but keep in mind, I think the best example is really male and female for nominal categories. So the next one, so in terms of increasing complexity, like nominal, sort of like this simple one, it's just like distinct categories, and you tick a box. The next one is what we would call an ordinal measure. An ordinal measure is similar to the nominal one, that there are distinct classes, different boxes that people can tick, this box, or that box. But now there's a natural ordering of these things. And you can sort these things in order. Let's say, do you go to the student bar all the time? Sometimes, never. You see, these are sort of distinct categories, but they are in an order. Obviously, the person who goes to the bar all the time goes to the bar more often than the person who goes there sometimes, or the person who goes there never. Yeah? But I still don't know what all the time means, or I still don't know what sometimes means. Is it 5 times a week? Is it, I don't know, 10 times a week? Is it once a week? Is it once a month? I don't really know. Yeah? So I cannot calculate an average here. But I know there is an ordering. And that's sort of like, depicted in this example, I don't know why I came up with horse races. Probably at some point while I was doing this, it was a horse race. I don't know. It's the final position of going through this finishing line. Right? There's a first, there's a second, there's a third, and so on. You don't know the exact difference between them. Sometimes one comes in a little earlier than the other one, or maybe there's a bigger gap between the second and the third, or maybe no gap, partly between the third and the fourth, or so on. But we're measuring the ordering. Right? And the classic examples of that would be if I ask you things like, I don't know, where the answer categories are very often, sometimes, never, or do you agree? I strongly agree, I agree, I'm neutral, I disagree, I completely disagree. These are sort of like, this would be now a Likert scale, I don't know, with these 5 different items that I have, 5 different responses that you could take. Yeah? But obviously there's an order here. If you agree, you're higher than somebody who disagrees. Yeah? Or if you strongly agree, you're higher, you agree more than somebody who just says agree. So these are ordinal measures, when you can order something. Okay, so let me move on and now talk about the next one. The next one, we call that interval measures. So again, it's sort of like increasing complexity right now, because before with the nominal, we just knew people belong to a certain category. Yeah? That is sort of all we knew. If there would be an ordinal measure, then we know which one is higher than the other one. Right? But we still don't know the differences between these two. Yeah? We didn't know, I don't know, what was the difference between the first and the second, and what was the difference between the second and the third, and so on. There could be shorter or longer time spans between them. I don't know, using this example of the horse races here. But there is a clear order in it. With interval, it goes even further, and with interval measures, there's actually, that's sort of why it's called interval measures, because between the distinct observations that you have, there's sort of like you can look at the difference between them, and this difference is meaningful. This difference is meaningful. Yeah? That's the thing about the true zero, and that's sort of like how it distinguishes from the ratio scale. But maybe the example helps to make that clearer. You could say, when you measure, let's say, the temperature in Celsius, so that's how I think about an interval measure. That's something that is at the interval measure. Why? Because it's meaningful to say that 25 degrees Celsius is 3 degrees hotter than 22 degrees Celsius. And that 30 degrees Celsius is the same amount hotter as 3 degrees than 14 degrees. There's sort of like this difference makes sense. 3 degrees warmer. Probably there's even a definition for it. Yeah? What an increase in Celsius sort of means. So this difference between these two things is meaningful. However, and this is sort of where now this no true zero point comes into play, you cannot really say that 40 degrees Celsius is twice as hot as 20 degrees Celsius. Because what does zero, do you have a zero here, but it's not, it is meaningful in the say, okay, this is sort of where water freezes and so on, yeah? But it's not an absolute 0 point here. So with interval measures, the interval, the difference between your observations, you look at them and you measure a difference of 5 here, and then you measure something else, a difference of 5 here. These two differences are the same. Or you can interpret them as the same. You can interpret them meaningful as the same. While in comparison, if I would have had the difference between very often and sometimes and never, these differences are not necessarily the same. Well, I hope that is getting a little clearer here now. Yeah? So with interval measures, you have something that is not measured on a distinct scale. You know, that's like something Celsius here, like like a continuous number, and the differences between similar differences between different observations are meaningful. They sort of mean the same. Okay. However, you cannot really say that, that when there's 40, that this is twice as much as 20. Is it twice? Why? Why not? Why not? Why not? Why not? Why not? Because when it's 0, well, I can maybe using the other example, because it would work if you would measure the whole thing in Kelvin. Kelvin is sort of like another scale of measuring temperature. It starts with 0, which is the absolute 0 point, which is the absolute 0 point in the universe, which is minus 272 something, which is when nothing moves in terms of atoms. I don't know if you wanted to know that. But anyway, so it's sort of like the molecules that just don't vibrate. They're just very still. And then they start vibrating, and this is actually, they have energy, and they sort of, they become warmer and warmer, and then, if you would look under a microscope, at some point these molecules will wiggle around like crazy. And that kind of is, they are warmer, they have energy. Yeah. So there you can see, there you would say, okay, 0 Kelvin is no energy. And then you would say, okay, if somebody has 10 Kelvin, there's some more energy in it, and somebody has 20 Kelvin, so they have twice as much energy in it than somebody who has 10 energy in it. But with Celsius, you don't have that. With Celsius, even if 0, well, actually, I started something explaining Kelvin to you guys. Yeah? So, because with Celsius, 0 degrees Celsius is actually plus 272 Kelvin. Yeah? So 20 degree Celsius would be 292 Kelvin. 40 degrees Celsius would be 312 Kelvin. So obviously 312 is not twice as 292. Some got it. Yeah? So, yeah. Maybe this becomes clearer when I'm now talking about the next one, the ratio scale. Yeah? So that's sort of now the most luxurious one, like you can start with a cute little tricycle, and now we're sort of ending up with a racing car, because it's sort of like variables that are on ratio scale. You can do much more with them compared to other ones where you just have yes or no, or where you just have a male or female. Ratio scale would be, they have all this, it's sort of like a continuous progression, like everything that is ordinal has the same properties as something that is nominal, everything that is interval has the same properties as something that is nominal and ordinal, and something that is ratio scale has the same properties as all the other ones, but it has something on the top of that which is a meaningful 0 point. And the example, that I could think of is height. Yeah? You measure the height of a person, and the difference between somebody who is, let's say, 140 centimeters and 150 centimeters is the same as the difference between somebody who is 170 and 180 centimeters. 10 centimeters, and this 10 centimeters is meaningful. It's sort of like 10 centimeters here is 10 centimeters there. Even though in the one case it's here, more or less, from 140 to 150, and there it's here, from 170 to 180. But the difference is the same. But now on the top of that, I can actually say that somebody who is 180 centimeters is twice as tall as somebody who is 80 centimeters. 90 centimeters. Yeah. Because now we have a meaningful 0 point here. Or if I would have measured temperature with Kelvin, it would be ratio scale as well. Okay. So we have, and there are no other scales. These are sort of like the four main ones that we have, and all the things that you can observe, that you can collect data on. They are on one of those levels. Yeah? If you go out and you collect data on, are you a student, are you a lecturer, are you something else, what would that be? Well, let's say if we take something out like probably salary or prestige or whatnot, it's actually a nominal scale variable here, or different occupations. Somebody has this job, somebody has another job. Without any further information, I cannot rank them. There's no order here. Unless I use something else, which is something, let's say, occupational prestige or so on. If I would go out and collect information about people's salaries, for example, which scale would that be on? Somebody has an idea? Ratio, that's correct. Why? Let's say if I earn, I don't tell you how much I earn, but let's say if somebody earns 20 euros per hour, that's twice as much as somebody who earns 10 euros an hour. Yeah? There's a meaningful 0 point. At the same time, the difference between 10 and 20 euros is sort of the same as the difference between, let's say, 100 and 110 euros. So the 10 difference here sort of is the same. That's sort of like would be the interval criterion, and having the absolute 0 point, that would be the ratio criteria, and then it's sort of like the most advanced one that you have. So salary would be ratio scale. Okay, now you could wonder, okay, what the hell, why are you bringing this up here? Why should we care about this? Yeah? And these are the kind of things you should know in the exam. Because they really matter for what you're going to do, what you can do with your data, how you can analyze your data afterwards. Because you can only do certain kinds of analysis when your variable is, let's say, ratio scale. Or you can only do certain kinds of analysis when your variable is at least ordinal scale. If your variable is nominal scale, you cannot do these kind of things. And essentially, now I'm going to talk about these three things, mean, median, and mode. If I have something that is measured on the nominal level, male or female, for example, I cannot calculate an average. That would be the mean. I cannot calculate a median either. Because a median, as you'll see in a second, would require an ordering, would require at least an ordinal level. However, what I can do is I can calculate the mode. The mode is simply the category with most people in it. So this is sort of like the things I want to talk about now, mode, median, and mean. And I brought a little example. Actually, this is the distribution. I remember a while back we had this funny little exercise where it showed you the weight of a cow, and you guys kind of had a guess on it. This is the data. This is actually the data. I analyzed this data on my computer, and you see how many people gave a certain guess, and this is sort of on the x-axis is the guess that people made. Yeah? You see that, and now I'm going to show you the example of what mode, median, and mean actually mean in this context. So I can look at the same data. This is now what you might come across this name. It's called a histogram. It's just bringing these sort of data together, data points, so that I have sort of categories, and at the end I want to see, okay, how is this distributed? But essentially this is just really what we call the distribution of this variable, of this data that we collected. And oftentimes this is sort of how I start my analysis. I look at the distribution of things. So how many people say this, how many people say something else, and so on. Right? And then I take it further from there. And why these distributions, they provide an overall picture of the whole thing. Sometimes you want to have a more crisp measure. Something like, okay, let's say maybe we can summarize this whole thing with a few key characteristics, with a few key numbers, and actually these are called descriptive statistics. Or actually, even more, I'm going to introduce measures of central tendency that are sort of like these key numbers to describe this distribution. Okay, and hopefully you'll see in a second why these things are called measures of central tendency, because here you want to know, okay, when do those, what is sort of like your most average guess of that cow? Ultimately I wanted to have the average guess of the weight of the cow. That's sort of like the data that I was intrigued by. Yeah? But I have 500 results, 500 people giving me a number. What do I do with these numbers? Right? And maybe you would say, okay, and that's actually what I did. The most straightforward thing to do is calculate the average, or we call that the mean. Yeah? That would be the average over all values. But that only worked because your guess of this weight of a cow was interval scaled, or actually it was even more, it was ratio scaled. It had a meaningful 0 point. That's the only reason why I could do that. If I would have asked you, are you male or female, I could have not calculated an average, a mean here. So the mode is the value that occurs most, median is the value that is in the middle of the distribution, and the mean is the average over all values. So now let's talk about each one of these a little bit. So as I said, the mode is simply the value of the relevant variable that occurs most often. Seriously, this is that straightforward. It's really just the number that has the highest frequency. So which number was guessed by most people? And in this case, it was actually 300 kilograms. So there were around, I don't know how many, 18 people who said 300 kilograms. You see, out of 500, this might be a very small number, but it is the guess that occurred the most often. The single guess that occurred the most often. And maybe now you already see the difference from the median or from the mean, because the mean could be very different here. So here I have a little example. Yeah? Like the mode, keep in mind, the mode is really just the number that occurs the most often. Let's say this would have been the observation that I have. These are sort of like certain data points, not too many of it. What is the mode of this? 1. Exactly. Why? Because there are 3 ones there. It's very straightforward. Right? So the next one would be 9s. There are 2 9s there. But here the mode is 1. That's the mode. It's very straightforward. And if I have, let's say, male or female, what would be the mode? Well, it would be, I don't know, how many people sort of show up in the most in one category of the categories that I have. Okay, let me move on to the median. So the median is now a little more, all these things give you a little more information, because I could tell you about the mode of a distribution. It's basically the number of people that guess. There's one guess that showed up the most often. But it might be at the very one side or the other side of the distribution. Right? It does not necessarily tell you about being in the middle. And this is sort of now where the median and the mean give you some more information, but you can only calculate them when your variables are at least ordinal, or then later on at least interval scale. So the median, we call that, is the point of the corresponding is the point of the score that lies in the middle of the distribution. So basically, if I would have taken all your guesses and I would have lined you up according to your guesses, small to large. You see, this only requires the ordering. It only requires a lining up that one is higher than the other one. It doesn't require me thinking about, okay, how much higher or so on. Yeah? That's sort of why it can apply to all those variables that where we don't have meaningful distances between things, but where we have a meaningful ordering between things. So if I would have lined you up according to your guess, and then I would have walked along, and at half of the person, at the 250th person, I would have stopped. I would have asked, what is your guess? That would be the median, if I would have 500 people to begin with. So it is about lining up your observations according to the ordering that you have, because it needs to be ordinal at least. Yeah? So you cannot do that with biological sex, for example, because you cannot order them. So which one would you put first and which one would you put second? So maybe now you see why it wouldn't work with nominal observations. So in this case, I had 100, I don't know, in total around 170 guesses that we had, and if I would have taken half of it, I would have walked through that, I would have also ended up with a score of 300. And oftentimes these things overlap, the mode and the median, or maybe, the mean not that much, but they don't have to. Yeah? So it tells me something more about, okay, 50% of the people made a higher guess, and 50% of the people made a lower guess than that. So in this case, again, the similar numbers, what would be the median? Actually, I already made you a favor. I already lined these numbers up from small to high. Now there's a natural ordering here. Median, you basically walk through so that you reach the middle. What is in the middle? 3, exactly. So 3. So there we are. So that is the median. The value that is in the middle. Yeah? There are as many values below or equal as there are values above or equal. So there you see, in order to do that, you need to have something that you can line up, right? If you would have country of origin, you couldn't line that up. Yeah? So because of that, you couldn't calculate the median. So that's sort of how these things relate with each other. The kind of analysis that you can do relate with the level of the variable and how it is measured. Or and that is in itself related to what it substantively stands for. Okay, you have another example. You see now I have different numbers. So now let's say I would have more 3s here. What would be the median in this case would also be 3. Because I line them up. I just walk halfway through and ask the person in the middle, what is your guess? What is your number? Would tell me 3 as well. But obviously the distributions would look slightly different. There's one complication about this. So what if, I don't know, let's say you have an even number of observations, what happens? Where do you stop? You would just stand in the middle of it. Then actually what you do, you look at the person to the left, the person to the right, and you take the middle of that. That's sort of like a way around that. Okay, so that's the median. Well, basically, to keep in mind what I'm doing here, I'm showing you these lower level things for something that we actually measured on a higher level, right? So we measured this weight of the cow, that's measured on the ratio scale. So we can go all the way up to calculating the mean. We can go all the way up to calculating the average, in a way. But for some other variables, you couldn't go all the way up, right? You're restricted to something. If you collected data about, biological sex, male or female, you couldn't even order things. You couldn't even calculate the median, not even to speak of the mean. The only thing that you could do would be calculating the mode, which is the category that has the most observations. So the mean, and maybe that's sort of the thing that you're most familiar with so far, the mean is simply the average. Yeah? You just sum everything up, and you divide it by the number of observations that you have, and that gives you the average. In order to meaningfully do that, you need to have interval scale, because then these differences between the points, they need to be meaningful for that. So if I have these couple of numbers, God, I make it so easy, I even reduce the number of numbers. So what is the mean here? Okay, actually, so in this case, okay. This is sort of like an example, maybe this is sort of easier. So let's say I have these other numbers, 11170. I add them all up, it's 10. In this case, I would divide it by 5 because I have 5 observations. That gives me an average of 2. So here you see how this comes about. Okay, so these are mode phenomenal variables. Basically, just which is the most common one, which is the category that most people have taken. Then you have the median, which requires, first of all, a variable where you have a meaningful order. Then you line it up according to that order, you walk halfway through, and then you ask that person, what is your number? Because then at the end, 50% of the people are higher, or same or higher, and 50% of the people are the same or lower. And then mean requires a variable that is at least at the interval scale, where you have meaningful differences between, let's say, 10 and 20, it's sort of like the same differences between 30 and 40 and so on. It also applies to ratio scale. That's even more advanced. You can do that as well. I can calculate. I can calculate the average height of people in that room. I could do that. I could calculate average salary. But and that is sort of like the mean. And these three different things, that's sort of like three different. They are called measures for central tendency. Measures of central tendency because they give you an idea about what is sort of like the tendency of people ticking certain things in the overall distribution that I showed you before. And the thing is, these things can be very, very different from each other. So this is now a funny little example of salary. And salary, actually, we do observe that a lot, that the salary distribution is very skewed. By that I mean there are only a few super rich people and lots of people at the bottom end. It's a skewed distribution. It's not like this or so, but it's sort of like there's like a high up and then sort of like, actually in this case it would be low, and then lots of people there, and then so it would be skewed. And this sort of like, now you have a number of people that kind of stand for how many people have a certain salary. And then if I would look at that, and that means like, I don't know, there are 10 people or how many people with a salary of 2,000. Obviously that is the category that happens the most, right? So that would be the mode. But it's not the median, because actually if I would line them all up, there's still a few other ones, actually the median would be higher up. So for that person, 50% of the people have a higher salary than 50% have a lower salary. But the arithmetic mean, or the average, arithmetic average, that's the mean, it's just different names for the same thing. Mean, average. Actually, there are different ways of calculating averages as well. That's sort of why it's called here arithmetic. There could be also the geometric average, but let's not complicate things. So it's just a different way of calculating this average thing. The average would be much higher. Why would it be much higher? Because there's one person which has a really high salary. So that one person would drive the whole thing. So in that sense, when you have like distributions that are very skewed or very sort of leaning into one side, that dramatically affects your mean, but not so much your mode or median. So we have these 4 levels that I introduced, with how you can measure something, and we have these 3 different measures for central tendency, and that's sort of like a simple way of describing the data. At the end, I don't know, I want to summarize my findings somehow, right? I cannot just write a report and say about everything that whoever took part in that survey, kind of what they said. That would be completely useless. I want to condense that information. I want to extract something, something more meaningful about the whole thing. And then I can say, okay, well, the average guess was actually this. Or this is sort of what most people guessed. And with nominal variables, you can only calculate the modes. With ordinal variables, you can also calculate the mode. I did that, with the actually, with something higher. I showed you which is sort of like the median guess that people have. Or the biggest guess, but also the median. With interval, you can calculate on the top of it a meaningful average, a mean. And for a ratio variable, it applies the same thing in that case. Okay, so these are sort of like the 4 levels of how variables are being measured and how they relate to relatively straightforward, simple statistics that we call measures for central tendency. But at the end, it's just, what is the number that occurs most? What is the number where 50% of the people have a higher value or lower value? Because you have an ordering, and the mean is the average, or like taking the sum and dividing it by the observations that you have. So that's sort of like the 3 things that I wanted to talk about, and about dispersion I'm going to talk on Monday, and also about the lovely things you asked me to talk about. So no reading for Monday. Okay, thanks guys. And read the exam preparation guide if you haven't done so yet.